This is the memory allocation and garbage collection activity in JavaScript. Well, I've got basically the whole folder open, the README file open here. This first step here, research memory allocation and garbage collection, I want you to do on your own. So if you haven't done that now, pause the video, go and do some internet research. Use your favorite search engine, your favorite AI tool, doesn't matter. But you're looking for information on memory allocation and garbage collection, specifically for JavaScript. There's quite a bit of information out there in terms of how it allocates memory, but more specifically in terms of the garbage collection, how it cleans up memory, how it keeps everything clean and nice and running nicely. What I'm going to do here today is we're going to explore these questions down below on Objective 3. So we're going to look at how objects are allocated, how they're deallocated in memory as we run through the code. We've also got some questions around managed and unmanaged. We'll get to those in just a moment, and then we'll talk about patterns and anything that we can do to directly interact with the garbage collection. I won't show the code for that last one, but we'll talk through really fast. So to explore these concepts, let me create a JavaScript file. Didn't mean to make that a JSX, just a JS. Let's just create a little bit of code here so we can play with some things going on. So we'll create a const or a variable here, a global variable, my value. I'll create a function called, I don't know, do something. And in here, let's create a variable, let a equal 2.0. We'll create another variable b, let it equal test. Let's do a loop in here. So we'll say for I, 0, I less than my value. So we'll go up to my value, I++. And let's just print that out to the screen. So we'll say print I. And then down below, let's do a print of b. And then finally, we'll return a. So just creating some code, random code here. And now down below, let's say my value equals do something. So we're going to overwrite the value of my value at the end of it. So we've got some code that's going to help us explore what's happening with the questions that we want to answer here. So starting off with the first question, how are objects allocated in memory? Well, the short answer is in our code, objects are allocated automatically, and they're done through a couple of different ways. The first are inline literals. So inline literals are any number or Boolean value or string that is inline in the code. So 3 is an inline literal. It's a numeric inline literal. 2.0 is an inline literal. Test as a string is an inline literal because it has the double quotes. So these are all inline literals. The other way that we create objects in memory is through the new keyword. So if I had something else be a connection, let's say new connection. We'll just do regular connection. So creating a connection, this new keyword also allocates an object in memory. So any inline literal, anything that's a number, anything that's a string, a character, a Boolean, any of these are going to be inline literals. Or if we use the new keyword, this is going to create an object. So any of these are actually creating objects in memory. So that's the short answer there. Again, two ways, inline literals and newing up objects. How are objects deallocated from memory? Well, the deallocation comes automatically for us, and this happens when a variable falls out of scope. So looking at the variable a is declared in the function do something, which means when the function is fully executed, when it gets to the very end here on line 14, then the value in a, which is 2.0, is now eligible for garbage collection, along with the variable a as well, but that's managed through the stack. It's managed a little bit differently. So the value 2.0 becomes eligible for garbage collection when this function executes. So the answer is a value, an object, or a variable becomes eligible for garbage collection once it falls out of scope, and scope is defined in JavaScript with curly braces. So this is a scope block. So anything declared inside the scope block is eligible for garbage collection outside of the scope block. In this for loop, for example, we create the variable I. I is only declared inside this scope block, even though it's not technically in the curly braces, it's still in this scope block of the for loop, which means I cannot call it from outside the scope block. Let me show you what that looks like really fast. So let's just run this file real fast just to show that it works. So 0, 1, 2, so we're printing all the values up to 3, and then we're going to print the value test. So that's what's happening today. If I add now here console log I after the loop, we're going to see that we get a reference error. It's saying that I is not defined. Even though we're calling I after the loop, the problem is we're calling I from outside the loop here. That's a problem. I is not available outside of this scope block. So the value I, the values of both the objects and the variable itself, are immediately eligible for garbage collection once the for loop is finished. So after line 9, those objects are now eligible for garbage collection. A and B have not been garbage collected because they were not declared inside the scope block. So these scope blocks are very, very important. In addition, we could even create our own artificial scope blocks. So for example, if I wanted to put B in a scope block and have it be eligible for garbage collection early, I could create an open curly brace and then afterwards a closed curly brace. Let me indent everything so it looks right. And now this lines 5 through 13 is an artificial scope block. That means that any variables declared inside, which are B right now, are going to be immediately eligible for garbage collection after line 13. So they're no longer referenced, they're no longer used, and they're available to be cleaned up. So that's scope blocks. So in JavaScript, scope blocks are done through curly braces. That's how we know when we have a scope block. Functions have a scope block. Loops, conditionals, these all have scope blocks. Classes have scope blocks. And in addition, we can create an artificial scope block where we don't have anything in front of that value. So again, running this, we can see everything works just fine. So that's the short answer, as short as it was. That's the short answer on question 2 here for deallocation. The next 2 questions, what is the difference between managed and unmanaged objects? In the JavaScript world, the answer is basically nothing because we can't do unmanaged objects. That's not technically true, but it's true enough for now where you are that I want you to just remember it. We don't deal with unmanaged objects in JavaScript. It's not something that we do. If you need to deal with unmanaged data or objects, things of that nature, you're better off using a different language. There are things we can do to work around that, but they're very limited in scope. So the short answer is we don't deal with unmanaged data inside JavaScript. The next question, are there design patterns or specific types in the language that can exist in garbage collection? With JavaScript, the answer is no. In TypeScript, there is a using pattern, a using for disposable. So there's a symbol.dispose method that we can use for TypeScript, and then we can use the using keyword. It looks actually very similar to C#'s using block. So that is available in TypeScript in some of the newer engines. So Node has implemented it, and it's being worked to be built into other browsers. For now, you may have to transpile code down. We're not going to get into that. I don't do too much in TypeScript with everybody. But effectively, for JavaScript, there are no real patterns or types that we use for automatically disposing of things in garbage collection. Last question, how can you interact directly with the garbage collector? There is a way to do this. I'm not going to go into that. You can do an internet research if you want to find out what that looks like. But there is a way to request the garbage collector run. We only have so much control over that. All we're doing is requesting that the garbage collector run. But it's still up to the garbage collection engine to determine when and if it's time to run. But there is a way to call into the garbage collector and suggest, hey, maybe you should do one. In general, we shouldn't do that. If you find that you need to do that, there's probably other optimizations we need to do in the code instead to make sure that the code is clean and it runs very effectively. That concludes our exercise for memory allocation and garbage collection in JavaScript.